Welcome to Real Physics. Today I will talk about Neil deGrasse Tyson. And to make it clear up front, I like him. He's a funny guy, a good scientist, a wonderful science communicator. He has a brilliant rhetoric, he's sharp-minded, and he's also careful about the meaning of words. So why did I pick him? I picked him because he is the textbook example of that American practical style physicist, as opposed to the European thinker of the past century, based in the tradition of natural philosophy. And this is, in my opinion, the deeper reason why contemporary physics finds itself in the mess we observe. As described in my book, Make Physics Great Again, America Has Failed. It is one of the most underappreciated facts in the history of physics, really a blind spot, how much physics changed and became another science, changed from the desire of understanding the true laws of nature to the technologically oriented enterprise of how to get things done. Now, coming back to Neil deGrasse Tyson, he's refreshingly scientific, demands evidence, calls out the bullshit, and yet he profoundly misunderstands the relation of physics and philosophy, as we can see from this recent podcast with Kurt Jaimungal, which I can recommend. It's a wonderful channel. We're going to look in some detail into that interview, and it might seem a little bit unfair to pick the scenes and dissect the words instead of taking them with a grain of salt, but I just cannot find a better representative of that ultimately superficial culture of physics that at the same time is so funny and spirited, which is part of the problem. And I do by no means claim that he is somehow responsible or even the founder of that American culture of technologically successful but epistemologically unsatisfactory physics. He's just a wonderful example to underscore the point I want to make. And yes, I admit, Overhyped Physicist is clickbait, because mostly I'm on board with the hype. And to make clear that at the bottom line I think he has great merits for physics, I want to show you a clip for which I absolutely love him. It happened at the Isaac Asimov Memorial debate a couple of years ago, and he asked, as he said, some purposefully blunt questions to Brian Greene, the chief propagandist of string theory, and yeah, let's just listen to that.
So you guys have been at this string theory for running on 2 decades now. And Einstein, working alone, went from special relativity to general relativity in 10 years, working alone. And it was a brilliant piece of work, and there was an experimental verification 4 years after he came up with the idea. Here you have legions of string theorists working 2 decades, and you're sort of not there yet. Is there just not enough of you? Are you chasing a ghost? Or are the collection of you just too stupid to figure this out?
I absolutely love that. However, I'm not sure whether he really wanted to criticize string theory, which is utterly unscientific, or just to poke fun on an otherwise respected colleague. Let's see this scene.
Why not then think of the very fabric of space and time as woven by the threads of wormholes of all of these entangled particles? And I thought that was kind of cool.
He thinks that is cool? I mean, wormholes are part of all this stuff with string theory, but it's utterly not observable, not scientific. It's a bullshit explanation for something we cannot understand. It's one of these fancy string ideas that do not explain anything. And I think there is a lack of the wish to understand that's related to how he sees physics. Let's see that definition.
That's how I think of physics. Physics is matter, motion, and energy, and every way that allows me to predict the future of those systems so that I can exploit it to the benefit of civilization and intellectual pursuit. That's how I think of physics.
These are more or less the lines how European style and American style physics distinguish. Here we have fundamental questions, here we have applications technology. Europeans, I'm talking always of the first half of the past century, Europeans were focused on understanding, why now we have just describing phenomena. the goal was insight, not just usefulness, as today we had individual thinkers and large communities, today big science. Now he faces a blow back from Kurt and he tries a second time to define physics. Let's see that.
I'd like to know ever more about how the universe works so that I can invoke it in the progress of civilization. And by progress, I mean new understandings. The history of this exercise often, hardly ever doesn't, convert to new inventions, new means of living, to prolong our benefits to our health, our longevity, and just our enlightenment about how the universe works.
This one I like much better because here he mentions the quest for insight that drives everything. And by the way, I don't want to be dismissive about the American style physicist. I mean, America has achieved many things which the Europeans did not. Take, for example, the Wright brothers. There was the European theoretician who proved that bodies heavier than air would never fly. And the Wright brothers, they just built the airplane, okay? So we have a difference in culture here, and both approaches are valuable. We just need both to make progress. And so I think at the very end he only scratches the surface of the essence of science here. Because I want to make this point. Take, for example, the confirmation of electromagnetic waves by Heinrich Hertz in 1886, which of course confirmed the theories of Maxwell and the ideas of Weber, but he was not driven by the idea of inventing something. No, he was just curious to measure the speed of these electromagnetic waves, and as a consequence we had this fantastic result that the speed of light was equal to the speed of electromagnetic waves, and in turn that led to a unification of optics and electrodynamics. And that kind of approach, that philosophical approach of unifying different phenomena into one big theory, that's something that always has driven Einstein and brought him to his great discoveries. So we have this continuous quest of trying to understand things, trying to get to the bottom of it, which accompanies the European style. And in contrast, look at what his idea of philosophy is. Let's see this one.
And so philosophers are there. Sure. That's where they belong, where they should be, as where philosophers were at the dawn of physics and the dawn of astronomy and the dawn of almost any field has a nice set of philosophers helping out.
No. This is completely wrong. I mean, it's not that you had philosophers, ancient philosophers, and they kicked off physics and then came the real physics. No, the philosophical attitude continuously accompanied physics with their deep questions, and then the experimental method came on top and yes, made physics a successful enterprise. That's true. The experimental method started in the 17th, 18th century, okay? Not today. And we have a long period of the most successful physics where the experimental method went hand in hand with the natural philosophical input of the people who wanted to know the real laws of nature. And he's talking about that philosophers and physicists parted ways. Look at this.
I see it as a practical reality of the philosopher no longer being as useful as they once were to the physicists asking questions on the scientific frontier. That's my view of this. If that's flawed, let me know, but that's how I see it.
Yes, it is flawed, because look at this quote of Lee Smolin, and he's talking about the problems of modern physics, how modern physics also theoretically went astray, and he identifies this as the deeper reason. He said, the work of Einstein, Bohr, Heisenberg, Schrödinger arose from deep thought on the most basic questions surrounding space-time and matter, and they saw what they did as part of a broader philosophical tradition in which they were at home. Okay, so we have in the most successful period of physics at the beginning of the 20th century, we had this constant influence of philosophy. So I think that Tyson really gets the history a little bit wrong here. He says that after 1900 there were no philosophers.
Mach's principle was a philosopher from the 19th century. Not so that's pre the era that I'm describing here, in terms of the value and influence of philosophers in the thinking of a modern physicist who's making actual discoveries. But there's not much after Mach that you can cite.
As if the physicists of the early 20th century had no philosophical thought. No, look at this.
John Bell of the Bell's theorems that we just mentioned, or the Bell's inequalities of the Nobel Prize.
Okay, John Bell. He mentions John Bell. That's a slap in the face, of course, because, I mean, you cannot dismiss John Bell here. John Bell with his very deep ideas, and he caused physicists to make experiments which were then awarded a recent Nobel Prize. But it's also interesting how Tyson sees quantum mechanics. There's nothing philosophical, nothing mysterious. It's just a tool to build something. Listen to this.
To me, the practicing scientist that's building circuit boards based on a complete understanding of how quantum physics works, I don't need to know that.
And that's funny, because that's exactly the same attitude that, as I describe in my book, Heisenberg encountered in the 1920s in America when he visited for the first time. While in Europe the atomic theory led to heated discussions, most American physicists seemed ready to accept a new view without any reservation. That were his words, and he recounted a meeting with the American physicists and said, "Oh, we in Europe are so concerned, we can't explain that reality, we don't know what it is it a wave, is it a particle, we're almost going crazy for this riddle." And the guy just retorted, "What's the problem? We call it wave-wiggler." Now, I find also this one beautiful when Kurt reminds him of that big riddle of the nature of reality. Look at this.
So number one, what is physics? Like, physics is understanding what reality is. So we have to put an asterisk on what reality is, because, like, who the heck knows what reality is? But physicists are trying to understand what that is.
I really liked Kurt's rant at this point, because these are the real questions we ought to ask. Why, for example, is space-time 3 plus 1 dimensional? I have a book about this. I mean, based on ideas of William Hamilton. You might agree or not with that kind of ideas, but we should agree that it is a relevant question, okay? And that's how, for example, Einstein approached physics. He said, I want to know whether the creator had a choice. And that is at the heart a philosophical question. So it's not about being useful or being good. By the way, was the atomic bomb good? Dropping it was bad. So physics is sticking to these philosophical questions to know the nature of reality. And interestingly, when he was confronted by Kurt that Bell was an important physicist who asked in this philosophical style, he raised a very strange discussion about whether Bell, John Bell, and Ernst Mach was trained as a physicist.
John Bell, wait, question to you. Was he trained as a philosopher or as a physicist? That's kind of my point here.
So, I mean, what does that mean? André Marie Ampère was not trained as a physicist. I mean, we owe him one of the greatest insights regarding electromagnetism. Johann Jakob Balmer was not a physicist, he was a math teacher, and one of the godfathers of atomic physics was his insight about spectral lines. Alfred Wegener was not a trained geologist, he was a meteorologist, and yet he revolutionized the field. And even in atomic physics, it was the Dutch lawyer Antonius van den Broek who in 1911 published in Nature a paper with the idea that the chemical elements are determined by the number of protons in the nucleus. This is one of the greatest insights of humankind, okay? So, being a physicist myself, I challenge the idea to lay utmost importance to that fact, and I would rather suggest a little bit training in history. That being said, I think if you look at contemporary physics, being a specialist is even detrimental. Because if you believe all these three parameters of the standard model in particle physics, or if you're a specialist trained in cosmology and you believe in dark matter and dark energy, you probably will not find anything fundamental in your career. You know instead what is needed for a fundamental discovery in the realm of cosmology and gravity? Mach's principle. And he mentions Mach's principle.
So you can mention Mach, and I'll give you Mach.
So he tries to give credit to one of the most important physicist philosophers of all times, but I don't believe he really knows what he's talking about here. Because if you're interested genuinely in Mach's principle, you're far out of mainstream cosmology, which he's not. Consider that Mach, in his thought was even more fundamental than Einstein. I've made many videos about this rotating bucket experiments, and let's sum this up in this nice caricature. There's Newton in the center, and then you have the rotating bucket, and Einstein is struggling with this concept of inertia and cannot explain it. And out there in the universe is looming Mach with his fantastic idea of gravity and inertia being related to the presence of masses in the distant universe. That is fantastic. And the general idea behind this, and we're not here yet, that the gravitational constant should be calculable by the mass distribution of the universe. Here again you see the difference between the American style and the European style physicists. Here is, oh, let's calculate the planetary orbit and let's do rocket science and explore all these things on the one hand side. On the other hand, let's explore the origin of gravity. Why is this force as strong as we observe it? The question of why is the mother of all natural sciences, as Schopenhauer said. And I want to circle this back to the other big discovery of Heinrich Hertz. Heinrich Hertz's confirmation of that formula that the electromagnetic constants are related to the speed of light are fundamental, not only because they unify electromagnetism and optics, but they reduce the number of independent constants of nature from 3 to 2 by the application of this formula. So if you manage to calculate the gravitational constants by other constants of nature or the mass distribution, we probably could have a similar important discovery as back then by Heinrich Hertz, if you continue to be a philosopher. But Tyson dismisses philosophers. Let's look at this.
Philosophers, you're not useful to us anymore. Sorry, we're going to keep going in our direction. Find something else to do with laboratories, okay, relative to armchairs.
So lab versus armchair, is this the question? I mean, what about Paul Dirac? Not to my knowledge that he entered the lab ever. So what about de Broglie, the founding father, one of the founding fathers of quantum mechanics, to whom we owe our profound understanding of matter? I mean, was he an armchair philosopher? Are you kidding me? Take Erwin Schrödinger, who at the same time being a founding father of quantum mechanics and was a cosmologist. Was he an armchair philosopher? I mean, all these people were certainly not good experimentalists if they have seen a lab from the inside ever. Now we have another very contrived statement.
We learned in the 20th century that most of the world our senses do not have access to most of what we will discover in the world as the 20th century unfolded. We needed large telescopes. We needed particle accelerators. We needed probes of the universe that do not issue forth from your senses being invoked on the couch, most of it. And so because quantum physics, modern physics, basically, post-classical physics is an era that the philosopher in the couch has no access to.
I think he gets this totally wrong and he mixes up two very different things. One thing is that you use, instead of your senses, also instruments, okay? But this was the telescope in 1609, and this was, of course, things you measured electricity with over all the 19th century. You had X-ray discovery in 1869, you had radioactivity. Okay, that's all fine, but all this physics was already done with instruments that substituted your direct senses, okay? But this has nothing to do with the era, we're talking from 1950, from the 1950s, of the big telescopes, of the big accelerators, and so on. You can't mix that up. Instead, that era after World War II, after the American culture of physics took over, after that, when physics really parted ways with philosophy, you had no real fundamental theories that worked. This is precisely the crisis of modern post-war physics. You do not ask philosophical questions anymore, you're just measuring senselessly. That, by the way, prompted me to say Americans don't like to think thoroughly. Nothing personal and many exceptions, but I'm talking about the scientific culture. The idea behind is, in our modern culture, that with enough funding, with enough labs, with enough people, you can achieve everything, okay? But this is not true. Big science is not great science. I mean, not that I'm not enthusiastic about all the fantastic data from the big telescopes, but I reject the notion that you will find anything fundamental with this mindless increase of energies in high energy physics and new accelerators. You don't discover anything fundamental. And historically, the reason is that after the war, the guys who built the bomb were considered the smartest minds. They were not. I mean, the building of the atomic bomb and the moon landing, they are maybe the technologically most spectacular events in physics, but they were not the supreme intellectual achievements of humankind. And there is another element I miss when I listen to Neil: humbleness. I mean, Einstein, Schrödinger, Dirac, they were all saying like, oh, there is so much we don't understand, yet they had this attitude of modesty. While listening to Tyson, it's kind of a permanent lecture. Okay, and I think Kurt is extraordinarily patient, but sometimes you should give him a little more time. Watch this.
So I think we're speaking past one another, so let me be precise, because I don't want to get misconstrued.
He asks for being not interrupted.
What I'm saying is that physics benefits from an understanding of philosophy. And also...
It did.
And he got 5 seconds in the end. And then he attacks consciousness and says that people do not really understand consciousness.
Since we actually really don't understand consciousness, and the evidence that we don't understand it is that people keep writing books on it.
And the evidence that they don't understand is they continue to writing books about consciousness. Okay.
To take two things that are not deeply understood and use one to explain the other.
I may agree on that, but you know where this happens? In astroparticle physics, where people relate their fantasies about the very first seconds after the Big Bang to their other poorly understand fantasies of elementary particle, what happens at the microscale of 10 to the minus 35 meters. That's also two fields which are linked and people don't know anything about anything. So go to your field. Okay, and I would even say we still do not understand the true evolution of the universe and cosmology. And you know what the evidence is? People are writing books about it. I know I'm a little bit mean here, but at the very end we have a problem of scientific culture, which is at the root of contemporary physics, and he just testifies about that problem. I think if we want to make progress in fundamental physics, we ought to go back at least to that kind of thinking in the 1930s and just think more thoroughly. If you enjoyed the video, don't forget to like it, and if you're interested in fundamental physics, subscribe to this channel.